Hey, hello guys. This might be interesting as I'm checking this layout. This is actually an original layout. I'm just making it for the first time, so I keep working on it. So do not expect that this layout is complete already. So be patient with that. I just found some minor errors, so I just fixed those, and I'm trying to avoid the jumpers the best I can, but it's sort of like difficult to do that. I'm almost done with this. I already have the power board. It's just a simple output power OPS power board. So I will continue working with this board, but it's actually a simple sort of like BGT type looking power board. This is a MOSFET amplifier that I decided to simulate a few days ago, and actually it's pretty good. I mean, I like the response of this amplifier. The supply voltage is actually 85 with 6 pairs, but it does not make any difference if you add more pairs. I already did that. I add 10 pairs. It's not gonna increase the power in watts. Is it reasonable? It will give you about 500 something watts. That's pretty good. um, what I'm trying to do is just to make a separate IPS single side, of course, driver board. So there were some few components that I forgot to add. So these two capacitors now are on the circuit. So right now I'm going to just show you an example right quick. That this is not complete yet. So what I'm gonna do is just make it larger, this PCB, so you guys can see what I mean. So I'm going to move this power board here, so it will be connected. I'm going to copy this layout, the IPS driver board, so it's going to look like this. As you can see, I try to make it as a separate driver board for this MOSFET amplifier. So right now, let me gotta make sure that I got align all these correctly. So they will be connected in this matter with wire. As you can see, I'm trying to make it simple, so separate board can be made for the driver board. So it's kind of I was trying to make it smaller, but it's kind of difficult because I'm not expert, but try to do my best. So right now I'm going to just place the wires like I'm making the connection for this design. So let me get some more colors. Let me see, multi-layer. So multi-layer we have more colors. So this one should be S2. This is just an example of how it's gonna be connected. So okay, C1 is gonna be red. This is the connection for the positive PD signal. We have the ground. So I guess the ground I should, let me see, this is the ground here. See, ground wire, it will be connected here, and this is the negative feedback of the output of the amplifier. It's okay. I just gonna place a wire this way. This matter. So this ground goes like this. Okay, I put it right here. So it's gonna be the ground. Set this to S1, and this one here can be green. I think it can be green wire. Green wire. So it's gonna be connected here. This is the green wire, and we have the positive, the negative. I think it's correct. Yeah, it's correct. So this one should be yellow wire from the negative voltage, and the PD. Let me see what color I can use. I'm just gonna use this one here, violet ND. Okay, let me see. All right, so this is how it's gonna look like, and the power and wires that will be connected here. So the reason I placed two fuses is because this amplifier will drain a lot of current. I was reading on the PDF file, the book. I forgot what page it was, so let me see if I can remember. No, it's not this one here. Let me see. I think it was page 400 something. I think, I'm not sure. Maybe let me see if I can find it. Well, audio amplifiers, I don't think it's this one here. I forgot the page. Okay, let me see. All right. There you go. This one here. This is the schematic that I found. So right, basically what I'm doing is the IPS driver board and separate OPS. So I gotta make sure everything is correct. I was doing on the simulation. I think I changed the voltage. I was doing some different voltage to see if I can. Actually, it can work with 55 volts. I already tried, but as you increase the volume, it will reach clipping faster because it does not have the correct voltages. Right now, let's say 400 millivolts. Let me see. That's the last reading. Okay. Okay, this one is pretty good. We got 35 watts. 35 watts. One thing that some minor changes that I did on the layout, I give it because I'm using a different MOSFET. I use more feedback, the IRFP 240 and the RFP 9240. So I had to give it a little bit more feedback and also gain. Here on R23 the original value is 1.2K, so I changed it to 950 so I can get a little bit more from this design. Let me see. I got it at I'm gonna change the load to 4 ohms low to see how it's gonna respond. Okay. All right, let's see. All right, we have okay, we have 70 watts. All right, let me increase the amplitude to see when it's gonna reach the clipping area of the amplifier. Okay, we got 500 millivolts. Okay, 111. Okay, 111 watts. All right, let's see. We got 139 watts. 0.0. Oh yeah, I'm actually using the correct voltage. Did I change the voltage? Yeah, I changed the voltage. 55 volt. And the distortion is it's not that bad. I mean, it's 0.073%. That's not bad at all. 1 kilohertz sine wave. So this is the way it's gonna look like. I might not build this amplifier, but I would like to at least have the files correct and save it for later. Maybe in the future I might be able to order a few PCBs like I always say. Anyway, I'm kind of short on money, but anyway, at least I have the how you say the motivation to continue doing this, because if you don't practice what you like, you might forget. So that's why I keep practicing all the time just to make sure I do not forget this. All right, I gotta fix this thing over here. So there you go, looks a lot better. So I will continue fixing this, making sure that I do not have any errors. Well, you want to try it out this, I do not mind to share the PDF file, but it might be too costly probably for you guys. Anyway, I'm going to save it maybe for later. Okay, I got a little bit. You can see I keep looking at the layout just to make sure I have the correct. I don't want the traces to be touching each other, so that's why I keep looking at it. So right now, if I take out the seal screen, I gotta look to make sure that I do not have traces that they are way too close to each other. So you can see here, I can adjust it to make sure that I do not have those traces touching the work. So right now, you can see this pad I think is too big for this diode, so I'm gonna make it smaller. It does not need to be that big. You can see that just to avoid any contact with the traces. That is really important. So I gotta do some cosmetic fixings here just to make sure that Everything looks nice. I try to do my best. I try to do my best. So this is an actual original layout that I'm making right now. So I gotta keep looking to see if I can adjust it a little bit more. Okay, on this transistor, before I cut the video, Q7 and Q6, the original transistor, I do not have those on my simulation. Those are 2SD669 and 2SJ. No, those are the MOSFET. Sorry about that. Those are the MOSFET. Sorry about that. The bottom ones I do not have on my simulation. So I wish I had those files so I can simulate with the correct ones. So at least these MOSFET, they are not that expensive. At least you go to Mouser, it's like $2 each. So if you purchase 10 of those, they're going to be like $1.67. I'm sorry, $1.67. I'll say $1.67. What the hell? $1.67. Damn it, cent. Oh my goodness. So this is the power MOSFET that they can be used on the N channel. As you can see, these can be used on the audio amplifier. So that's why I gave it a little bit more of feedback. On the negative feedback, that will be R15. As you can see, I can even increase this value to 66K probably. Let's say 65K. So it will be more sensitive, having more feedback, because I think that it will need more feedback as well. I don't think this power MOSFET, they respond really well for audio. Probably, I'm not sure. Let's say now that I increase the feedback, let me see. The problem is that after you increase that resistor, it will have more THD problems. So that's why you gotta keep that resistor in a reasonable area, like 56K. 56K I think is the value that it will respond really well on this design. Let me see, I gotta move this. You can see it will keep the distortion. Right now it's pushing 139 watts. I'm not trying to push the amplifier too much. 0.074% THD. So that's it. Alright guys, have a good day. I will continue with this layout. It's interesting. I gotta keep my mind busy. Alright guys, have a good day.